All right. What's up, everybody? So this is September 1st, and today I'm gonna back up a little bit and cover some more of chapter two. I talked, so I was looking at the videos, and I know last week's lecture was really long and winded. So what I think I'm gonna do here going forward is shorter videos, more shorter videos, so we can kind of you can only learn like 20 minutes at a time is what the theory is. So take a break after 20 minutes, recuperate. Furthermore, I'm going to do a lot of practice problems, and if you feel like you have some of this stuff down, you might not need to. You can like kind of skip to the next part or whatever. But anyway, what we're doing today is, like I said, I'm going to back up a little bit. We're going to go over chapter two. So I did all that talking last week on last week's lecture and realized that I skipped some of the important things that I needed to go over. And I also didn't use my PowerPoint. So I provided these PowerPoints for y'all, and they follow along with the book, so they're very similar. Um, Let me make sure y'all can see. They're very similar to the book's layout. So I'm going to start here today at 2.5, writing conversion factors in the text. That'll look like this page here, which is page 39. Okay. So, and like I said, it's essentially the same things on the PowerPoint as in the text. Um, Either one you want to follow is fine. I'm going to stay with the PowerPoints. And these are different math skills. So anybody that is in um, medicine or like physical therapy, anything like that, my future nurses, um, anybody that's in the health sciences. Okay, so there's a little bit of basic math that you're going to need or that you should understand in order to just be better at your work, right? So um, we're going to talk about these. I'm going to give you some tips and tricks to analyze like word problems and different stuff like that. Where's my PowerPoint? Okay, so the first thing we're going to look at is equalities, and this just means two things that are equal to each other. I'll pull up my iPad here. Okay, and the reason I bring this, not this page. So, two things that are equal to each other. So let's start with, let's say time. So 1 hour is equal to 60 minutes, right? And I'll just abbreviate that. All right, so I can set this up two different ways. I can either say 1 hour over 60 minutes, or 60 minutes over 1 hour. Sorry, my pen's sticking real bad. Um, and the way you set it up is based on what kind of problem you're trying to solve. Okay, so there's all these different equalities, right? We got different ways of expressing temperature. You'll see here I got 2.2 pounds is equal to 1 kilogram. A pound is equal to 16 ounces. And I can set them up any kind of way I want to. I can put either one in the numerator or the denominator. Okay, so I didn't realize they had 60 minutes in an hour, but this is the same thing I just did on the page. So an equality is just setting two things that are equal to each other. All right. So when I do it, say I do it, a lot of times what I'll do is if I just have one thing, like say it just gives me a mass, I'll write 60 grams over one, right? Just so that I have it in a conversion factor, and then I can manipulate it how I want to. You'll see what I'm talking about here in just a minute. We're going to do some practice problems, and I'm going to need to decide whether or not I have, say, 60 grams. I just did whether I have 60 on the top or whether I have 60 on the bottom. And that'll be determined by this unit right here, right? If I multiply these two by each other, I can cancel out gram. Okay, so I'll pay attention to the units, and that kind of tells me how to set up my equality. The equality being this 60 minutes per hour or 1 hour per 60 minutes. Okay, that brings up another point that I want to make. Anytime you hear somebody say the word per, you need to think about it being like a fraction. Okay, x over y. Okay, so if I say density is grams per milliliter. All right, the first thing you should think is grams per, right? This little division is the per, grams per milliliter. Okay, can go for all kinds. There are 60 minutes per hour, or there is 1 hour per 60 minutes. Okay, so you'll see per whatever in a lot of these practice problems, and I want you to think is that's like a signal that tells you I need to put this in a fraction. Okay, so anything per something is is divided by that. All right, so let's go back to this PowerPoint. Um, Conversion sig figs. If you have any problems with sig figs, you can email me. There's a couple little kind of tricks that they'll try to throw at you, trick problems, I should say, they'll try to throw at you. If you run into one of those, you can, and you're having problems, email me and kind of show me your work. Maybe write it out on paper and then send it to me, and I can see what's going on. Okay, so write conversion factors from the equality for each of the following: liters and milliliters. So essentially what it's asking is it wants to know the conversion factors for liters and milliliters. All right. So if I didn't know anything, I would go to my text and I'd look for or a table of some sort that shows me the different units. Right here goes that table with milli is 0.001 of a meter, okay, or it's 10 to the negative 3. So I'm going to write this on my iPad real quick. I'm going to say, what do we say? I don't want to write it like that, that'd be confusing. 1 meter is 1,000 millimeters, okay? Now I can write that in a few different ways, right? 10 to the negative 3 meters is 1 millimeter, okay? And I got that from my table here. You see this 10 to the negative 3? That's relative to the meter, all right? So just to show you the other way I would do it would be a meter is equal to 10 to the 3 millimeters. All right, so this goes back to that thing I was telling y'all, the trick about are you getting bigger or smaller? Which unit is bigger in size? The meter is bigger than the millimeter, right? So that means the meter number has to be smaller than this one. Okay, so if it's larger in size, it's smaller in number. If it's smaller in size, it's larger in number. Notice that, so 10 to the negative 3 is less than 1, but a meter is bigger than a millimeter. 1 is less than 10 to the power 3. I'm right here. 1 is less than 10 to the power 3, but a meter is bigger than a millimeter. Okay? So that's the relationship when you're doing the different powers. Okay? So anyway, back to this problem that we're working on. Liters and milliliters, I said 1 meter is over 1,000 milliliters, and I can do that either way, 1,000 milliliters over 1 liter. Meters to inches is going to be a little more tough. I might need to do a couple. So meters to inches. First thing I can do is, so one thing that I do know is that 2.54 centimeters equals 1 inch. Okay, so let's set that conversion factor up first. 1 inch over 2.54 centimeters. Okay, so now what I want to do is let's set up the problem a little differently. It says it wants to go from meter to inches, right? So what I'm going to do is I'm going to say inches is on the equals side. Equals inches. So the reason I'm doing that is you want to set up the problem whichever one you're trying to find. Whichever it asks you for, that's what I'm going to put on the equal side. So the final thing in this one is says it wants me to go from meters to inches. So meter is going to be on the left of the equal sign. Excuse me. Starting my problem, and inches is going to be on the right. So I will start over here with a meter. I'll leave some space and I'll say equals inches. Okay? Now I can start doing conversion factors. As I said, 2.54 centimeters is equal to 1 inch. So I set it up per 2.54 centimeters per inch. So I have a centimeter here and a meter here. Let's do how many centimeters are in a meter. Okay, so there are 1 meter is equal to 100 centimeters. Okay, and if you want to check that, you can go to your text. Let me see if I can do it quickly. Text centi is 0.01, right? 10 to the negative 2, but I went the opposite way, so it's 10 to the positive 2, which is 100. Okay? So 1 meter equals 100 centimeters, and I think I have everything here that I need to get to inches over here. Okay, so what you want to do is you want to set this up where I multiply everything and it cancels out. Okay, so how would I do that? We said that 1 meter, let's set this back up again. 1 meter is equal to, well, 1 meter is where we started. It's not equal to anything. So I just, remember I said I like to put stuff over 1. I'm going to start by putting this 1 meter over 1 because it really doesn't mean anything yet. Now I need to multiply that by something to get rid of meter. I just introduced centimeter, so let's do that. 100 centimeters over 1 meter. Now notice that I flipped it from this one here. This one I have 1 meter on top and 100 centimeters on the bottom, but if I flip it, these meters cancel out. So that's why I've done that, and that's why it's important. You remember, you can always just flip these over. So now I've done that, let's do the final equivalent, which was 2.54 over 1. Now I need to end up with inch on top. Okay, and just so, let me illustrate that a little better here. Inch over 1. Remember, I can put anything over 1. So x inches over 1. Notice that I have the inches on top on the right. So I need to make sure the inches is on top on the left too. So I'm going to need to flip this 2.54 centimeters over 1 inch. 1 inch goes back on top, so it matches this side right here. And then the 2.54 centimeters goes on the bottom, and that's correct because we know that's correct because I can cancel out centimeters. Okay? So the way you set up these problems is so that you cancel out the units as you multiply it and end up with just what you're looking for in the solution, which is inches in this case. So now I can go through here and multiply 100 divided by 2.54. We'll say it's like, what, 40 something? Yeah, like 45-ish, 46-ish, something like that. I'm not going to do the calculation, but by inches. Okay, so 1 meter is equal to approximately 46 inches. All right, that's how you do it. That's how you move through your different conversions. Okay, and you're going to get a lot of practice in this. Let's do a couple more. Why not, right? Meters to kilometers, that's fairly simple. We'll skip by that. In a problem. So remember how I said per? When we say 85 kilometers per hour, this is how you can set it up. You can think of that per being the fraction, the division symbol. Okay, 85 kilometers per hour, or 1 hour per kilometer. Okay. Let me see if I got another practice problem. Percent factor. So anytime you see a percent, just remember that a percent is something over 100. Okay, if I have 100%, it's just like saying one. Okay, it's 100 over 100. Um, that's how I usually set up percentages. Whatever percentage they give me, I put it over 100, and then you put the whatever units they give you. This one for the this example says 18% body fat by mass. Okay, so the by kind of works like per. If you see by something, um, that's essentially a division symbol. Okay, so 18%, 18 over 100. That's where I got the 18 over 100 was the percent, and then the fat over mass came by fat by mass. All right. Um, 1.9%. So this one's pretty easy. I would write it. Well, I think they do. Do they do it? I'm not a big fan of the percentage problems, but we'll do one. So 1.9%. I would just say 1.9 grams over 100 grams. So that takes care of my percent right there. And then whatever the units is giving me. So salmon contains 1.9% omega fatty acids. So it doesn't say by mass or by anything. Um, doesn't say, it doesn't have anything. I know they're talking about mass, but I'm not very happy about the way that's worded. So I just say 1.9 grams over 100 grams, and this 1.9 grams omega fatty acids over, I don't know, over what? Over massive salmon? I don't know. That would be my guess. Okay, over the total mass of the salmon. 1.9% of it is in omega fatty acids, which actually seems pretty high. So it must be a high content of good fatty acids. That's what I take away from that. All right, so study check conversion factors for each of the following. 1 gallon of gas is 340. Um, yeah, so this just wants you to practice setting up your fractions. The first one says a table of aspirin that contains 325 milligrams of medication. So I would say 325 milligrams per. Um, I think that should say tablet of aspirin, um, right? And then the next one says 18% gold in jewelry, so I'd say 18 grams over 100 grams, and that's gold per mass of jewelry, right? So 18% of the weight of the jewelry is in gold. Jewelry. The last one says 1 gallon of gas is 340. So you can write this. I mean, you can do this with any one of them, remember. You can flip it upside down, 340, or it's 340 per gallon. Okay, so this is just setting up your conversion factors. You shouldn't have any problems with that. Let's do a problem. I want to do a problem. We did meters to inches, so that was even more difficult than centimeters. So this will be a good study check right now. Go ahead and stop and try to do this one. Use the, you're pretty much doing the same thing that we did here, except for you don't have to go to inches, right? So you can just plug in the 2.44 meters here, 2.44 meters over 100 centimeters in a meter, and then I carry it out. You tell me how long the centimeters are on the right side, okay? Let's see. Using two or more conversion factors, so you'll see that sometimes you have to work quite a few steps and you have to get through a lot. You have to get through a lot of units. Let's do another practice problem. How many minutes are in 1.4 days? I like this. Okay, so clear all this. Okay, so on the left side it says minutes, right? Oh no, excuse me, it says how many minutes, so that's actually what we're trying to find. So I'll put it on the right side. How many minutes, X minutes, are in 1.4 days. So on the far left, I'm going to start with 1.4 days. I'm going to put that over 1, okay? So, and I'll always start my problems that way. It just makes it easier for me to set up these conversion factors. So 1.4 days. Now down here, I am going to, this is actually written kind of sloppily. Let me try to do it better. 1.4 days. My writing is never going to get better, but I might can get better at organization. All right, X minutes are in 1.4 days. So now I'm going to start setting up conversion factors. How would I get from minutes to days? First, let's do hours in a day because I want to go from left to right. So there are 24 hours in a day, 1 day. And now I need to go from hours to minutes. So there are 60 minutes in 1 hour. Okay. So now I have all my conversion factors. I need to figure out a way to set this up so that I can get from days to minutes. Now remember, when I'm setting them up, I want to cancel out days. So this first one looks like I'm going to want the day on the bottom. So 24 hours up here. There should be a little space there. Let me see if I can make it. Maybe put a little dot. Multiply. Okay. 24 hours. All right. And now here I want to cancel out hours to get to minutes. So hours need to go on bottom because hours is on top here. So 1 hour here and 60 minutes here. All right. So now if I go through and I cancel out the terms, 1 hour, it leaves me with just minutes here and just minutes there. Okay, so that's how I know I'm right. If I have extra units somewhere, say if you had an hour down here, then I would need to put an hour on the bottom over there, and then I would know that that's not correct. I did something wrong. All right, so then I can just go through and carry out the problem. I got a calculator here. 1.4 times 24 times 60 equals 2016 minutes. 2016 minutes in 1.4 days. Okay? And then I'd rewrite all of this. 1.4 days equals 2016 minutes. Okay. Um, if you want, well, I guess everything's going to be online. I was going to say I'd like to see your work. If you're not getting the right answer, and you want me to check what you're doing, write it out on paper. However you're doing your problems. I'm doing mine on this iPad, so there's nothing to really save. But if you write it out on paper, send it to me. I can look at it and see where you're going wrong or what you're doing wrong, where you're getting caught up at. And usually it's something really simple, like you forgot to include one of the units or you squared the units. What I mean by square the units is, let me go back here. If I had, if for some reason I set this up and I had 1.4 days and then I did times 1 day over 24 hours, then my equal side would have day squared, day times day. Okay, so now it doesn't make much sense when you talk about days, minutes, hours, but when we talk about like grams and milliliters, remember centimeters cubed is the same thing as a milliliter. So you're going to see exponents in some of the solutions, and you might think it's okay, but a lot of times you've made a mistake. So make sure your units match up with your solution units over here match up with what the question's asking. Remember, this one said how many minutes. If I have anything other than minutes on the solution side, I've messed up. Okay? So that's that. Now I want to get into density. And I talked about all of this so that when I say mass per volume, you know to set it up as a fraction. And so that's what density is. Density is a fraction. It is grams per milliliter or grams per cubic centimeter or grams per cc. Um, there's all kind of different ways that it can be expressed, so it's important that you realize anytime I say per, I'm doing the division symbol, and you can write out whatever they're saying, and then you'll see that it's a mass over a volume. Okay, remember there's all kind of different volumes. There's liters, cubic centimeters, which is the same as a cc. That's a short name for cubic centimeter, cc. And then milliliter is a volume that you'll see a lot in density. Grams per milliliter. Okay, so remember that any mass over volume is a density. Okay. So let me go to here. Let's talk about water. Let's talk about density in general a little bit. Where's my pad at? Let me get this back here. Okay, so density equals mass over volume. And here I've shown you some equivalents. Grams per milliliter is the same as grams per cubic centimeter and is the same in kilograms per liter. Now, one exception that you might have to pay attention to, this is not what I want to text, is they express the density of gas in terms of grams per liter, I think. Yeah, grams per liter on this far right. All these are gases. So you're going to have to think a little bit differently if they tell you it's a gas. So you need to pay attention to that. Solids and liquids work the same way, but gases are a little different when it comes to density. So just keep that in the back of your mind. Maybe make a note of it on your study guide going forward, because I'm sure they're going to try to throw something at you where they say this gas has a density of blah blah blah, and then you'll set it up trying to do it the same way as solid. So be careful about that. Now water is 1.00 grams per milliliter. So that is important because 1.00 grams over 1 milliliter. Okay. You'll also see it written like this, grams milliliter. Okay. Oh, I'm not on that page, sorry. Okay, so, or this. All right, so you'll either see it written like this, 1.00 over 1, but more than likely you're going to see it written like this: 1.00 grams and then a little slash milliliter. It's important that you remember you can set it up as a fraction: 1.00 grams over 1 milliliter. Okay, and I always do that. I always set it up over 1, even if I don't have anything there. Just gives me something to look at, something to work with, something to keep my units on the right plane, right, either below or above the division symbol. So anyway, water, I don't know, I didn't look at up why, but water is like the standard. The reason that water is 1.00 grams per milliliter is because we built the milliliter off of 1 gram of water. Okay, and you'll see that in chemistry and sciences a lot, where we take something that's very common, very known, say water, and everything else is based off of that. Celsius, for example, 0 degrees Celsius is the freezing point of water. 100 degrees Celsius is the boiling point of water. That's not a coincidence. We set it up based off of water. We did the same with density. Density is 1.00 grams per milliliter. So if I say you have 24 milliliters of water, and water is 1 gram per milliliter, then I can make a conversion factor and say that, well, 24 milliliters over 1, multiply this, milliliters cancel out, and it's 24 grams. Okay? 24.00 using sig figs or whatever, right? Because I got this is 3 sig figs. So 24 grams, excuse me. So anyway, all that just to say 1 gram of water equals 1 milliliter. 1 milliliter of water equals 1 gram. Okay, so that's a very helpful conversion that you'll be able to use in a lot of these problems. And so we're going to go back to this, and I think you'll see that if you keep that in mind, it's going to help you with this section of the course. Okay, 1 gram of water is equal to 1 milliliter, and you'll see here different densities. All right, so now let's talk about relative density. The relative density, and when you hear somebody say something's relatively, that means compared to something else. Okay, so relative density is called specific gravity. All right, and that is just saying whether or not it's denser than water. Okay, so the density of a sample over, let me make sure you are seeing what I'm saying. Maybe not a little bit. Let me bottom out a little bit. Okay, so the density of a sample over the density of water is specific gravity. And what does that mean? So let's just put some things in there. Oil, for example, is usually less dense than water. Okay, so let me clear a place on my iPad. Let's say oil has a density of 0.80 grams per milliliter. Okay, and then water, we said, has a density of 1 gram per milliliter. All right, so then oil is less dense than water, and my specific gravity would be 0.8. Gravity equals 0.8. And it doesn't have any units. Specific gravity doesn't have any units. It's kind of just like a relative term, almost like a percentage or something, right? And there again, I said relative. You'll hear that a lot. It just means compared. It's compared to something else. It's not a unit in itself. Like I compared 3 grams with 2 grams, but the ratio would be 1.3, and that doesn't have a unit, right? Because I had grams compared to grams, they canceled out. So anyway, specific gravity of oil in this case would be 0.8, and that means it is less dense than water, and it would float. Okay, so this is essentially what specific gravity tells you, is whether or not something's going to float. If it's less dense than water, it'll float. If it's more dense than water, it'll sink. So rocks and stuff are all like made out of metals and heavier components that are usually like in between 2 and 10 grams per milliliter density, they're all going to have a high specific gravity, like greater than 1. All of them will have a specific gravity greater than 1. 10 over 1 would be 10, so that item would sink very quickly. All right. Um, I think that's good. Oh, the density stuff. So I did want to show you the density triangle. Now I included some videos on YouTube that kind of go through and do some practice with this and do more illustrations about how to use this. But remember we said that, let me go back to this original page, density equals mass over volume. So let me write it like this. D equals little m over big V. Okay? So one thing that came up with to use this was called the density triangle. Okay, so it is essentially, let's do this like this. Okay, so now how can I do this? Let me do just me. Just for a second. All right. Is that gonna work? That's not gonna work. Dang it. So whatever, wait, is it gonna work? It could work. So this is my density triangle. And just to pull it back up here, and I'll actually put a little line. Make sure this line comes all the way across, and then I'll put one there too. Okay, so the DMV, right? Everybody's most hated place, the DMV. And we call this the density triangle. So now, when you get a problem for density, it's going to ask you to solve for one of these variables. It's going to ask you to solve for either the mass, the density, or the volume. Okay? So whichever one it asks you for, you need to cover up with your hand. So say it asks me for the density. I'm going to cover up density, and then in order to solve that, I'm going to do mass over volume. Okay, we'll do some practice here in just a second, but I wanted to show you all that. So let's say I ask for mass. So I'm going to cover up mass. I'm going to try to anyway. I'm going to do density times volume. Okay, and then if it asks me for volume, switch hands. Pop. I'm going to do mass over density. Okay, so this is a way that it's kind of helpful for doing density problems. It's going to give you one of these three or two of these three, and it's going to ask you to solve for the other one. And so whichever one you're solving for, you just cover up and you use the other two values they gave you, mass over volume in this case, density times volume if you're solving for mass, and then mass up over density if you're solving for volume. Okay, so let's do one practice with that, and then that'll be it for the day. We'll get started on chapter 3 next time. I'll probably do that tomorrow. We'll probably get right into that tomorrow. Like I said, I'm going to try to post shorter videos more frequently. So let's see if there's a practice problem. Okay, here goes one study check. Let me find where that is for y'all. Okay, an unknown liquid has a density, so I'm going to write this into my pad while I leave y'all on this page. An unknown liquid has a density of 1.32 grams per milliliter. The volume, what is the volume of a 14.7 gram sample? Okay. I can't write, it's taken, of the liquid. Okay, so now I'm going to pull this over here. Now I didn't set these up any kind of way. I just wrote down what I have because I want to figure out exactly what I have before I set it up. And I'm doing that mainly because this is a density problem and I'm going to use the density triangle. Okay, remember usually I'll set it all up over 1. I'll do this whole 1.32 grams per milliliter over 1, or I could go ahead and move milliliters to the bottom, 1.32 grams per 1 milliliter. Okay, there's different kind of conversions you can use, so I'm not going to get into that just yet because I don't want to confuse you, but just know that you can set it, you kind of have some freedom on how you set this up. Now that can mess you up, but it also will help you to figure out ways to solve the problems quicker, okay, more quickly. Okay, anyway, I digress. Let's go back to the density triangle. So remember, in DMV, I'll set up a little one here, DMV, little triangle there, bop, bop. Okay, so this is a density, right? Because I have grams per milliliter. Anytime you have mass per volume, it's a density. Density. Make sure I can see that, okay? Now 14.7 grams is a mass, okay? So this is, I'll do a little equals down to the side, a mass. And it's asking for the volume. Clear all this. So volume is going to be on the right side. Let me leave a little space. X volume. And since they gave me a volume and density of milliliters, I'm going to use milliliters for my answer because I know that's the unit that I'm going to end up with. So let's erase that and let's put milliliters. Okay, so now back to our triangle. I'm solving for volume, so I'm going to erase, but essentially imagine I'm covering up the V. Okay, so M over D is what I'm going to try to do. I'm focusing on this part right here, right? M over D, mass over density. So set this up again. 14.7 was my mass, divided by the density, which was 1.32 grams per milliliter. All right, so now if you can't really see it the way I've set it up here, let me set it up a little differently. 14.7 grams over 1 times 1, not times, it's divided, so when you divide fractions you invert and multiply. 1.32 grams 1 milliliter. Okay, that is a 2, you can't tell. Now, and the reason I set that up, if you'll notice, is to cancel out the grams. That's how I knew that I was going on the wrong path when I started to multiply the 1.32 up top. So the grams cancel out and it leaves me 14.7 divided by 1.32 equals 11.14. 0.14 milliliters. Okay, so I would like to rewrite this. Let me do that. 11 point, we'll call it 1. So 3 sig figs, and both of my values there. 14.7 had 3, 1.32 had 3. So my final answer will have 3 as well. Okay, 11.1 milliliters is the volume of this unknown liquid. Okay, so that's kind of how you do density problems. The triangle makes it much easier. Knowing about the conversion factors and how you can flip them and manipulate them is also very helpful. So if you have any questions about that, let me know. You'll have a lot more problems like that, like this, in lab this week and in the next section, in the upcoming section. So I'm not going to harp on it as much, but I will be looking over Mastering Chemistry and see how you are doing there. Let me know if you have any problems. I can work some more examples and maybe post videos. There's also a lot more problems on Mastering Chemistry that are like the ones that I've given you. And are like the ones that are in the book. So if you see any in the book that kind of catch your eye and you say, I want to know how to solve this, send me a picture of it or whatever you're working on, and like I said, I can do videos, example problems, whatever you need to help you understand it better. All right. So this PowerPoint's available on Cougar View. Let me show you where. Right here under Chapter 2 Content, I'm going to add this video there as well, but I will add the link to the announcements page. Density is technically Chapter 2, so like this is going to be an addendum to that, and all this material that we're covering today, or this video, I guess is the only thing that will be added to Chapter 2 content. Okay? So that's that. Y'all let me know what you think, and I will see y'all tomorrow for lab and the start of chapter 3. Bye.